So here we are. Welcome to our intro Data Viz workshop. So let's first talk about what can we actually do with data. And I know I was talking, basically I'm going to repeat what I said before I turned on the recording, is that data allows us, doing data visualizations allows us to basically explore the data in a way that's not just staring at it in its tabular form, because our brains are designed to better process pictures. You can see all sorts of these different scatter plots and other types of charts here that, they can, this is actually an example from the iris data set where it's comparing 3 different types of irises. And, you can see things like petal width, petal length, sepal length, as plotting all these kinds of relationships, and you can see the differences in data. And that might be something that's harder to see when you're just staring at a table. So data allows us, data visualization and doing exploratory data analysis really lets us lets us discover insights that can inform whatever process comes after, whether it's a machine learning model that you want, an algorithm that you want to build and implement, or just preparing a report and doing an analysis. So how do we do this? We're going to use a couple tools today. Mostly the 3 on these slides. The 4th one is kind of like on your own. I picked the data set that we're going to use today, so we're going to ignore Kaggle. But Google Colab is going to be our Python environment. We're going to be using Google servers, a virtual machine on Google servers, in order to run our Python code. Pandas is probably the Python library right now for data manipulation. It allows you to take in CSV, Excel, all sorts of these data storage files and look at them in a really pretty way. Seaborn is going to be the main library that we use to actually visualize and plot the data. And we're going to go over 3 different chart types today. And then finally, you see Kaggle. Kaggle is a very popular repository for finding open source data. But like I said today, I put a data set in our shared Google folder, which I'll show you all how to get to. And that's what we're going to use. So yeah, let's create a Google Colab environment. So I know, have all of you used Google Colab before?
No.
Okay, yeah, so then let's quickly go through how we set this up. Liv, if you see here, this little quick graphic, if you go to your Google Drive and you click New, and then you click in that More drop down, and then where I circled Connect More Apps, you'd want to click into that and search up Colab and add that to your drive. And if you're using a school account, you might have to switch to like a personal one. We've had that problem in the past. So I can also show you how this would look. One more slide. Let's make some visualizations. Yay. So we go New, More, Connect More Apps, and then you can search up Colab in here. And then once you do that, you'll have this, you can install it. But last time when we did this, we created a new notebook. Today, we're actually going to be just copying this notebook that I made. So it's in the shared Google folder in Cohort 1, but I'll also send a link to it right now to you all in the Zoom chat. So that you
also, sorry to cut you off, Max, but you can't use the Umish email, I'm pretty sure. Umish doesn't have Colab. I don't know if you already went over that, but.
Yeah, I mentioned that if you're using a school account, you might run into an issue.
Okay.
So you still need to enable Colab if you haven't yet, but do that on your personal account, and then you can access the link that I just dropped in the Zoom chat. And let me know when you all get to this page. You can give me a thumbs up, or you can just go ahead, go to File, and save a copy in your own drive. So yeah, I would just save the copy in your drive, and so that this will be your notebook that you're going to be following along with as we go through this together. You can see here, while you guys do that, some learning
objectives. You're muted for me.
I'm muted?
Oh, wait, never mind. Sorry.
No worries. So I was just saying, while you guys are creating a copy of this notebook, let's just talk a little bit more formally about what we're doing. We're going to learn about the seaborn library, the different plot types we get into it. I kind of already explained why EDA is important, but we're going to see that more here. And hopefully we can gain a little bit of intuition for, it's great that you can just pick any 2 features in your data set to visualize, but maybe thinking about why, or what kind of feature would I want to do for a scatter plot? What kind of feature would I want to use a histogram for? Stuff like that. So I'm going to assume that you've all saved a copy to your drive at this point, so we can go ahead and move on. The first thing you want to do when you get to this environment, you guys are all here, right? Thumbs up. Awesome. So let's, mine says reconnect, but yours will probably say connect. So we want to connect to our runtime on Google servers. It'll go through that. And then we can start installing the modules you need. You probably won't need to do this. You might say, for me, requirement already satisfied, but just to be safe, we can go ahead and do that. Great. Now let's mount our Google Drive. So we're going to mount Google Drive to this notebook in order to access the data that we need to use for this workshop, because what happens is that we're going to load in a data set that's saved in a CSV file in the Google Drive folder. So in this case, if you go to the Cohort 1 folder, there's this data set, there's this .csv, separated value file called some data, and this is a data set that I put in here that we can all use today. So if we go forward from there, let's run this cell to import drive. Lovely. All you do is just sign in with the Google account you're using, and it'll give you a little code to put in the cell. Once you allow it its permissions, copy, and then you just paste in the code. And then we Okay, sweet. So now it says mounted. So now if I actually open up this little folder here, I can see that in my drive, I can access any file that's in my drive. You can see I have quite a few. That's okay. Depending on where you put this notebook, I hope that you put it in the top folder of your drive, though it's not really that important. We have to actually switch our directory to where our data set is located. So I don't know where you put your shared folder on your Google Drive, but all of you will start out with this %, change directory, and then you'll go to drive, my drive. In my case, I have Cohort 1 right in the root of my drive, or at least I have a shortcut to it. So I can just put /cohort 1, but it might not be the case for you. So if you need to go through whatever other subfolders to get to your Cohort 1 folder, I would do that. But if I run this, it'll tell me, I went to content drive, and then, it skipped my shortcut to Cohort 1. And if at any point, if you guys fall behind, please feel free to stop me. This is a pretty small workshop, so we can work at everybody's pace. Are we all CD'd into the right folder?
Can we wait like 2 minutes?
Yeah, of course.
Thanks. Because the Cohort 1 folder was shared with my school account.
Gotcha.
But I'm like, I can't use that.
Mm-hmm.
Okay, so it's in my drive now. So what are we changing?
So you want to go change directory, put a % ahead of it. It's a %tell is a magic command basically, and it allows you to do things like, you might want to run from your command line, but you can do them right in your notebook. So you put $CD, and then in quotes, you start at the outermost lowercase drive, then you can go into my drive, and then my drive is the equivalent of what this is right here. So in my case, I have the Cohort 1 folder here, but you might have a couple other folders before you get to it. And so you would put those folders in order, essentially, until you get to Cohort 1. Exactly like this. All good?
I'm getting an error.
Okay. What does it say?
It says no such file or directory. But
Yeah, I can't find one.
Yeah,
Okay.
I put it in mine though.
Okay.
Like, I don't see a shared folder. That's what I'm trying to look for.
Oh. Do you have this shared Cohort 1 folder?
No, I just have the shared hello data.
Interesting. Okay. Darn. Let me quickly add you. Do you want to put in your email in the chat so I can?
Yeah.
Can I put mine too?
Yes, please.
I don't know why it's not showing up either.
Yeah, no, I'm sorry about that, guys.
Oh, you're good. I wasn't sure if it was like automatically supposed to go, so I was trying to search it.
No, yeah. I just assumed that you guys. I guess that's my bad. Okay, so you guys should have that folder now. I would add it to your root directory, and then you should be able to switch directories to this Cohort 1, which has our slide decks and some resources for web dev stuff too.
Okay, now I see it.
Awesome.
Okay, so now I can just have it as you have it, like /Cohort 1. Okay.
Yep. As long as that folder itself is placed in the root of your Google Drive, in my drive.
Oh, it works for me now.
Sweet.
Perfect. Okay.
Liv, are you there?
I'm just double checking to make sure that the
Gotcha.
folder is live.
Yeah, you just probably have to right click on it and say add to my drive or something like that, or add a
Yeah.
shortcut to my drive, one of those two.
Okay. Now we're good.
Okay, sweet. So let's keep going. We're going to start by importing the two libraries we just installed. So import pandas as PD, seaborn as SNS. These are just industry standards. It's just easier, as you can see on the next line, when we want to read in our CSV file, instead of calling pandas.readCSV, we can just say PD. And then this second function, data.head, or really .head, just allows us to take a peek at the first 5 rows, which is pretty cool. And you guys can actually see the data that I picked out for us to work with.
Did you go over what seaborn was again?
Seaborn is a graphing library that is designed to, have you heard of, remember how in the linear regression workshop we used matplotlib?
Yeah.
Seaborn is like matplotlib, but fancier.
Okay.
Yeah, that's really all it is. So you read in the CSV file that's in the cohort 1 folder and do data.head to just take a peek at the first 5 rows. And looking at this, can one of you tell me what you guys think, what kind of data set this is? Like what domain does it fall under? What do you think?
What does that mean?
Like
I don't really know.
what's the topic here? Like what are we dealing with apples? Are we dealing with bananas? Are we dealing with
Oh,
mangoes?
is it cars?
Close.
No,
It's
not
close.
cars.
Not cars, but close. We have lot
Buildings?
area, buildings. Okay. What kind of buildings do you think specifically?
Houses?
Yes, this is a housing data set.
Okay.
Yeah. So we're dealing with a housing data set here. So we have features like quality, condition, lot area, and garage area. We have a bunch of these other specialized features. We have year sold and sale price. So a lot of the times, housing data sets, you can run linear regression algorithms to predict sale price, but that's not what we're doing today. But we can make some visualizations that kind of show the relationship of sale price and other features in our set. So let's move on. The first thing I immediately noticed when I loaded this in is that I got this weird indexed column, unnamed 0. It looks like that, the index didn't get written in correctly when the CSV was saved. So the first thing I want to do quickly is just drop this column from the data set. And the solution to this is in a toggle right here. So, I mean, there are more exercises like this. So I can pop this one open, and we can see that we just set our data frame equal to data.drop this unnamed 0 column that really means nothing to us. And we specify axis equals 1. And all you need to know about this is that when you see axis equals 0, it's referring to the rows. And when you see axis equals 1, it refers to the columns. So I'm just going to say data equals data.drop. And then we put the name of the column in quotes. We have to put it exactly how it's written. And then we specify axis equals 1. And so we call data.head to make sure it went through. And great, it's gone. So that's, a quick little bit of pandas stuff for you if you've never worked with this before. It's pretty interesting. Now I want to, let's pick one of these columns. So this data structure with this tabularized data, it's called a data frame. But we can select one of these columns individually, and that would be called a series. So a bunch of series are what make up data frames. So if we pick data overall quality and run that, it's a 1 to 10 scale of the house's quality. We can see that we have 1,460 records, not 59 because we start at 0. So we know that we have, and you can see here length is 1460. And so all these houses, they're rated on a scale, and that's just part of our data set. Is everybody with me so far? Yeah?
Jason just popped in, Max. So.
Yo, Jason, what's good, man?
Hey, Max.
How
Yeah,
are
I'm not following, but don't worry.
All right, no worries.
Jason.
Varun, feel free to share the shared Google folder with Jason so that he can follow along in this notebook as well.
Oh, yeah, for sure.
Great. Okay, so let's keep going then. Is everybody, we've all gotten to this point in the notebook, yeah?
Yeah.
Okay, sweet. So enough of pandas. We're here for seaborn. We're here to make pretty plots. So let's do that. It's based off of matplotlib, like I mentioned earlier. And let's talk about the first kind of plot we're going to be using today, which is a distribution plot. So essentially, it's just going to be a histogram, and to plot it is super similar, super easy, actually, I should say. And to plot it, we're just create a variable for our graph. We're going to call SNS, and we're going to call the distribution plot function. And A is basically specifying our axis, kind of, what, in this case, an axis refers to like the data itself that we're actually plotting. So I want to plot the overall quality that we just took a look at on a histogram. So this is literally all you need to do. If I run this line here, you'll get this slightly funky looking histogram. So as it turns out, there are like several things going on here. This definitely doesn't look like your histogram from stats class. So why did that happen? Well, seaborn, when it plotted this, it made a guess for the number of categories or bins to divide our data up into. So you see these empty spaces here where seaborn created bins that don't actually exist. So given that we have a 1 to 10 scale here, how many bins do you guys think we should specify in order to get a cleaner graph? Open mic here.
Probably 10, right?
Exactly. So how would you think we want to specify 10 bins? To give you a hint, it's similar to how we picked our axis here. So I'll start for you. I'll say sns.displot, and we're going to say A equals data overall qual. And then I'll give you I'll give you a bonus. I'll even put a comma here. What do you think I should write to specify how many bins I want? And definitely don't look at the little thing that just popped up that kind of gives away the answer. What do you think I should type?
Bins equals 10.
Yep, that's literally it. And you can see this little toggle has a solution as well. 10 bins. We want 10 bins. And if we replot this now, oh look, that's something we're a little more familiar with. Except for one other thing, right? What's this like weird curve across the bars? And why is this y-axis scale so weird? So to summarize, you don't need to worry too much about this, but this curve is plotting something known as the kernel density estimation, excuse me. And so that's based off a probability density function, but that's a little bit beyond the scope of what we're gonna be going through today. But if you're interested in learning more, I did make a short little toggle that has some more information about KDEs. So feel free to dive into that now or after. For now though, let's just specify that we want to remove the KDE. So we'll just say KDE equals false. Again, keeping the same axis, same bins. And once we remove it, we see that that little curve is gone. And the y-axis actually also changed its scale. It went from, a probability to an actual count. So now we can see that, if we have these are 6, there's like a little over 350 houses that are rated overall quality 6. And this follows, as you might, if you've ever taken a stats class, as you might expect, it follows a Gaussian or normal distribution. So here's some more reference from Seaborn. The documentation for Seaborn is pretty dang good. So definitely refer to it if you ever want to know how to do something. I can pop this open real quick so you guys can see what's going on. It's just taking you through an example. This tutorial is sort of just saying, as soon as I can scroll, just grab a random array, size equals 100, make histograms. It's basically doing everything that we just did. So cool, let's move on. So that was the first kind of plot, which was a distribution plot. Now I want to talk about categorical plots. And so these are super useful for guessing, for plotting categorical variables, or ones that are, they're not numbers necessarily. So you wouldn't like sum them or aggregate them together, Does that make sense? Yeah. So now we're going to plot a count of all the differences in the foundation. So let's go back to our original data frame and let's take a look at the foundation. So each of these houses, they have a different type of foundation. There's some with brick, some with cinder block, some with concrete, some slab, some stone, and some wood. They're all over the place. And I can tell that, this one has a brick one, this one has cinder block, and so forth, The idea is that, for each of these 6 foundations, there's only a 1 in one of the columns because the house only has one type of foundation, essentially. So let's figure out how we're going to do this. I'm going to create a new data frame called foundations, and I only want to specify the last 6 columns because those are the only 6 columns I care about, because that's what I want to make my categorical plot from. So how do we do that? We can use a little bit of pandas here. So we're going to call data.indexLocate, And the way this works, it takes 1 or 2 arguments. It takes the rows you want, and then it takes the columns. So we want to select all the rows, but we only want to select the last 6 columns. Does that make sense? Because those are the 6 columns where the features that we're concerned with are located. So to do this, we put a colon that basically just indicates everything, all the rows, and then we put -6 to the end. So we select the last 6 columns all the way to the end. And if you've done any kind of indexing with Python before, this might look familiar to you. So if we do that and we look at the head, we can see that now we have successfully isolated the 6 columns we want. And this is .head, so we're only looking at the first 5 rows. But if you printed out all of foundations, if I can type correctly, we can see that we'll have 1,460 rows and 6 columns, which is pretty cool. So now let's talk about how we can actually count these all up, right? We want to find out, how many foundations are brick, how many are cinder block, and so on. And so the way we're going to do this is going to be by grouping these features together. And now pandas allows us to do something called GroupBy, which allows us to vertically collapse the data frame into rows where they have a similar attribute. However, you might have guessed, or I'm sorry, you might have noticed that what I'm suggesting is to kind of collapse things horizontally. So what we actually have to do first before we can use pandas' GroupBy is to sort of melt down the data frame, or another word would be to unpivot it. So we want to take this 1460 by 6 columns and kind of flip it. We want to make it'll be 6 times as long, but only 2 columns. And I'll show you what this looks like. As you see, another description of what's going on here. We're going to unpivot the 6 columns to just 2. The type of foundation that it is, and whether a house has it or not. So we know that a 1 means true and 0 means false. So let's melt down our foundations data frame. And all we really say is foundations.melt, and then the variable name that we specify is going to be foundations. You can put whatever you want in here. It's kind of arbitrary, but it's helpful to, to understand what you're doing. So now if we run this block here, we can see our foundations column that we just specified here. And then pandas, when we melted it down, it actually created this value column for us. And now we see here that we actually have 8,760 rows. And that's 6 times the amount that we started with, which makes sense. There are 6 options for each foundation, right? So this house, for example, each house, there's 6 possible options, but there's only gonna be a 1 in a single one for each single house. Does that make sense so far? Please stop me if you guys have questions. I mean, I'm kind of flying through this notebook right now, so I'm totally happy to slow down. Okay, sweet. We can keep going then. So we want to group them together using pandas again. So we're going to take our foundations melted and create a new data frame out of it. We're going to have a new variable, foundations melted and grouped. And what this will be is we're going to take our original data frame, foundations melted, and group by this foundations column that we specified. And we don't want to group it as the index. Don't worry about it. And then what we want to do is take an aggregate of everything. So we're going to group them all by the type of foundation, and then we're going to take the sum. So let me ask you a quick question. What do you guys think this data frame is going to look like when we group them into 6 categories and then take the sum of each category? Let's start with something simpler. How many rows do you think this data set is going to have? We're grouping into 6 categories, right? So how many rows would we have?
You would have 6, right?
Exactly. Yeah.
Yeah.
Yeah. And what do you think the value is going to be? Like, what do you think, like, not what specifically what the number is, but what is that number going to represent?
Oh, like the total number of houses that have that
Precisely.
kind of function.
Yes. So if we do this, exactly that. We have 6 rows, and we can see the values for how many houses have this kind of foundation, how many houses have that kind of foundation. And we can see here, we actually can quickly see that it's pretty close between cinder block and concrete. And so we have the data. Now let's just plot it. So we're going to call the categorical plot. So this time we're going to do sns.catplot, and we're going to specify our x and y axis. So in this case, I put the y first and the x second. Just to make it look prettier. You'll see why it looks better once we actually plot this. And the data we specify to use is going to be this foundations melted and grouped. And since it's a categorical plot, you can actually specify what kind of categorical plot you want. And in this case, I think a bar chart makes the most sense for our purposes because we want to see the comparisons. So let's plot it. Look at that. We've, just like that, one line of code, we managed to plot this data that we managed to isolate and aggregate from our data frame. And we can see here very clearly that these two are pretty much in close competition and everybody else is kind of like irrelevant. It'd be pretty interesting to me, honestly, to examine the relationship between maybe these houses and maybe this type of house. Maybe I would venture to say that they're probably like older. They were built, you know, way earlier. But that's something else that you might want to explore on your own. But again, that kind of goes to show you the power of data visualization and like how to think about a data set and how to think like a data scientist.
I got when I tried to run that piece of code, it gave me an error message.
Okay, what was the message?
It says name error line 2.
Is that it? Does it specify like where?
It says name foundations melted group is not defined.
Did you run this block up here?
Oh no, I didn't.
That's probably why, because that variable wasn't created then.
Okay, it works now.
Sweet.
I have a question about the melt. Sorry, what were you saying?
Nope, you're good. You had a question about melt?
Yeah, I'm like still confused how the melting part worked.
Okay, sure. So let's talk about this a little bit further. So what happened here is that we had this data set with 1,460 rows and 6 columns. And so what we did here is unpivoted it. So you can see how, you know, there's 1,460 rows for each of these 6 columns. And so by unpivoting it, we basically took this column and made it into a whole row, we basically imagine stacking these on top of each other, right? So we had the 1,460 brick tile ones, and then underneath it, we put the cinder block ones, and underneath that, we put the concrete ones, underneath that, we put the slab ones, and so forth. So that created 6 times as many rows in our data set. And this is basically how pivot and unpivoting works if you've ever worked with that in Excel, for example. Does that make a little more sense?
A little bit. It's still not completely clear though, but that's okay.
No, I mean, we basically took, you know, all of these rows, there were 1,460 rows in each of these 6 columns, and we just stacked them all on top of each other. And then and that's what this foundations column is.
Oh, I get what you're saying.
Okay, and then each one of them, they have a certain value. And so imagine having them in groups of 6, where each 6 represents a house, because we have 1,460 houses here, right? And we have 6 options for the foundation. So we're gonna. So
now you're like splitting up the 6, so that's why you have 6 times the number of rows. Okay.
Exactly.
Makes sense.
Okay. Does anybody else have questions about melting or anything else? And I put a little description here. I apologize for this last bit right here. I appropriated some material that I used for another program that I'm a part of, and I forgot to edit that part out, but that's okay. So in that case, if I don't hear any questions, we can talk about the last kind of plot that we're going to look at today, and that's going to be a regression plot. So regression plots are primarily used for plotting the relationship between 2 quantitative variables. So we just looked at categorical variables. Now let's look at some quantitative variables. And we can plot a best fit line really easily to see if there's a relationship. Now, this is a little bit different from linear regression because we're not like necessarily plotting, you know, we're not getting the algorithm for doing that line. We're not coding that today. We're just plotting the best fit line through the data. One that minimizes something called the residual. So you can look that up. I mean, a little bit beyond our scope right now. Again, to make this graph pretty simple, like the other 2, we do sns.regplot, regression plot. We specify our x and y. I want to look at the lot area and the sale price because, I mean, I have a hunch, could be wrong, but I have a hunch that the lot area is somehow correlated with how much a house is worth. And the data, we're going to specify our original data frame. We plot that. And wow, what is going on? We can see that, we have a whole bunch of houses under this like 25,000 square foot mark. And then a bunch of these outliers that kind of like mess up the whole graph, because you can see like, maybe there's some kind of relationship, maybe, I don't know, but they kind of mess up, we can't actually tell what's going on in this cluster of where most of our houses are. And you can see that this blue line, that's our best fit line, though it doesn't really mean anything to us. And this highlighted area is something known as the confidence interval. And that's just basically a measurement of how well did this best fit line do. So what if we wanted to just take a look at the meat in our data? We can do something called creating a mask on our data frame, and we can kind of hide all the values where the lot area is greater than 25,000. And so let's do this. We have this small lots variable that's going to be, we're going to take our data and we're going to apply the mask to it. That's what the first set of brackets are for. And we want all of our data where the lot area column is less than or equal to 25,000. So basically what this is going to do, it's going to kind of apply a filter to our data set where it only keeps the rows where the lot area is less than or equal to 25,000. And then we can do .describe, which is another function similar to .head. But as you see what it actually does, it gives you a whole bunch of summary statistics: the count, the mean, standard deviation, the minimum, the quartiles, and the maximum. And you can see here, if let's take a quick look. We only lost about 20 entries. If you look at the count, we started with 1,460, and we lost what is this? 31 entries. Yeah. So it's not actually that bad what we did here. We didn't actually lose a huge amount of our data by doing this. So now let's replot it. Can somebody tell me how we can replot this graph? Just want to unmute and just recite, and I'll type. And if you're looking for help, there's a little solution right here. You can click on your notebook, or you can look up literally just right here. So does anybody want to help me out here?
I tried using what we had above, but that just gave me the same plot.
Well, let's take a look at that. Why do you think this is? We specified the area, we specified the sale price. Those would be the same. But what about our data variable? We said that our data is going to come from the data frame. But we just created a new data frame here, right? Don't we actually want to use this kind of data frame instead?
Oh, so it would be data equals small lots instead.
Yep. So
Okay.
Let's do it. SNS.regplot. Let's say x equals, what was it? Lot area. Yeah, that's how you spell it. Y equals sale price. And data equals, what's it called? Small lots. Yeah, that's what we're looking for. And I'm going to throw in a bonus in here, actually. I want to change the color of my best fit line. So we can specify something called line underscore keywords, which is actually going to take the form of a dictionary. And we're going to say color red. And if I did this right, which I hope I did. Okay, I didn't do it right. String indices must be integers. What did I do wrong? Oh, I put the small lots data frame in a string, but I actually wanted the data frame. And look at that. We have a slightly better representation of what's going on here. We isolated just to where, lot area is less than or equal to 25,000. And we can actually clearly see where our best fit line is. And you can see that the confidence interval actually, it got a lot tighter, which is good for us. So we can see there's probably a slight correlation, but you can't really know for sure just by looking at this. You can actually calculate something known as the R-squared value, but I'm not going to do this right now. If you want to, this link here will tell you exactly how to do it, and you can take a look. And what the R-squared value will tell you is how much of the variance, like how much of the variability in our scatter plot here is explained by the line of best fit. But yeah, that's going to wrap this up. We went over 3 different kinds of plots, and we learned a little bit about seaborn, and we kind of thought about how do we pick features to use for plotting data. Sometimes you want to use strictly categorical variables, sometimes it's quantitative, sometimes it's a little bit of both. And then one step further, which variable does it make sense to examine the relationship of? And most of the time this actually falls onto domain knowledge. I kind of opened with, what kind of data set are we working with? Are we working with apples? Are we working with bananas? Like, so much of visualizing data is understanding the data that you're looking at and being able to pick out, oh, this would make sense to look at with this. But yeah, now you can pull your own data sets. You can use Kaggle. You can follow a very similar workflow to what we did here and create your own visualizations and, hopefully discover something cool. But I'm going to wrap that up here. Please, questions, QA, open forum here.
So would this whole thing still work if you're pulling data from like an Excel spreadsheet on your computer?
Yeah, absolutely. Instead of using pd.read CSV, you'd probably want to say pd.read Excel or something like that. There's a pandas function, and if you ever want to look up how to do that, pandas, how to read Excel spreadsheet in pandas. Google it. And then, it kind of tells you. You can port Excel right. You don't even need to do this stuff, actually, but unless you want to specifically drill down into what data. But the pandas documentation, fantastic. Pandas.read Excel. There's your answer. And if you ever have issues finding, how to do something, Google it. Trust me when I say that I did not pull all this stuff from the top of my head. I had to Google, how do I make a regression plot? How do I melt a data frame? Believe me, I did not know how to do that when I started this notebook. But, I Googled it and I figured it out. And that's a whole lot. That's going to be a very familiar part of your workflow too. So I would get used to doing that as well.
Hey Max, so is seaborn? So seaborn's a library, right?
Correct.
Is it derived from pandas or something?
No, but they're often used together. Seaborn is actually derived from a library called matplotlib, where it's kind of like the original graphing library, and Seaborn was kind of written on top of it, and it just makes it look a little cleaner to read. That's all it is.
Mm-hmm. I see. So pandas is for the data part, and then Seaborn's for the graph, like
yes, exactly.
graphical.
And that they work together because they can take in pandas columns, because in the end of the day the series can just be written as a list.
I see.
But
okay,
this data structure allows it to be read a lot quicker as well in runtime.
Okay, thank you.